Hello, in this lecture I will answer on two questions. In the first question, we find out the value of line segment X that is inside a rectangle. In the second question, we find out the value of the green area that is inside a semicircle. So we start with the first question. In the drawing, we have rectangle ABCD. We know that inside rectangle ABCD we have a circle, and we know that the length of the tangent from point A to this circle is 33 degrees. The length of the tangent from point B to this circle is 85 degrees, and we are looking for the length of the tangent from point C to this circle that is unknown, so it is equal to x. We are looking for the value of x. And finally, we also know that the tangent from point D to this circle is 35 degrees. Again, our mission is to find out the value of line segment X. It is the tangent from point C to this circle. So, first of all, we define the center of this circle as O. We define the point of tendency of the tangent from point A to this circle as E. We define the point of tendency of the tangent from point B to this circle as F. We define the point of tendency of the tangent from point C to this circle as T. We define the point of tendency of the tangent from point D to this circle as M. And we will join points O and E together by a straight line. Point O is the center of the circle, point E is the point of the circle itself, therefore OE is the radius of this circle that is equal to R. And according to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. Here we have tangent AB, that is tangent to this circle at point M. Point M is the point of tendency. Therefore, we have the radius OM that is drawn to the point of tendency. Therefore, tangent AB will be perpendicular to the radius MO. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees according to rule number 1. We can implement rule number 1 in our drawing, because in our drawing we have the radius OE that is drawn to the point of tendency. Therefore, according to rule number 1, this angle will be equal to 90 degrees. We will join points A and O together by a straight line. By joining points A and O, we actually created here the green right triangle, triangle AOE. So we implement the Pythagoras theorem on the green right triangle, triangle AOE. So in the green right triangle, triangle AOE, by PT is the relation for Pythagoras theorem. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is AO, therefore the square of the hypotenuse is AO squared, and it must be equal to the sum of the squares of the perpendiculars, that is to say, it must be equal to OE squared plus AE squared. I repeat again, according to the Pythagoras theorem, in the green right triangle AOE, AO squared equals to OE squared plus AE squared. So AO squared equals to OE squared. OE equals to R, therefore OE squared is R squared plus AE squared. AE equals to 33 units according to what is given as the question, therefore AE squared is 33 squared. So in conclusion, we found out that according to version number 1, the right triangle AOE, AO squared equals to R squared plus 33 squared. In the next step, we join points O and F together by a straight line. Point O is the center of the circle, point F is the point of the circle itself, therefore OF is the radius of this circle that is equal to R. And we have the radius OF that is 1 to the point of tendency, therefore according to rule number 1, this angle will be equal to 90 degrees. In the next step, we join points B and O together by a straight line. And we will implement the Pythagoras theorem on the right yellow triangle BOF. In the right yellow triangle, triangle BOF, by PT we get that BO squared equals to OF squared plus FB squared. Repeat again, in the yellow triangle, yellow right triangle, triangle BOF, by PT B all square equals to OF square plus BF square. So B all square equals to OF square. OF is R, therefore OF square is R square plus FB square. FB equals to 85 units, therefore FB square is 85 square. So, in conclusion, we found out that according to question number 2, B all square equals to R square plus 85 square. In the next step, we will join points O and T together by a straight line. Point O is the center of the circle, point T is the point of the circle itself, therefore OT is the radius of the circle that is equal to R. And we have the radius OT that is bound to the point of tendency, therefore according to rule number 1, this angle will be equal to 90 degrees. So we join point C and O together by a straight line. And we'll implement the Pythagoras theorem on the right orange triangle OTC. The right orange triangle OTC according to the Pythagoras theorem, we get that OC square equals to OT square plus TC square. Repeat again. In the right orange triangle OTC by PT, OC square equals to OT square plus TC square. So here OC square equals to OT square. OT is R, therefore T square is R square plus TC square. TC is X, therefore TC square is X square. So in conclusion, I found out that according to question number 3, in the right orange triangle OTC, OC square equals to R square plus X square. And finally, we join points O and M together by a straight line. So here point O is the center of the circle, point M is the point of the circle itself. Therefore, OM is the radius of the circle that is equal to R. And we have the radius OM that is going to the point of tendency. Therefore, according to rule number 1, this angle will be equal to 90 degrees. We join points O and D together by a straight line. And we will implement the Pythagoras theorem in the right peak triangle, triangle OMD. In the right peak triangle, triangle OMD, by PT, all D squared equals to MD squared plus MO squared. Repeat again in the right peak triangle, triangle OMD. By PT, OD squared equals to MD squared plus MO squared. So here, OD squared equals to MO squared. MO squared is R, MO is R, so MO squared is R squared plus MD squared. MD is 35, therefore MD squared is 35 squared. So in conclusion, we found out that according to equation number 4, OD squared equals to R squared plus 35 squared. In the next step, I will copy the 4 equations that we created here by Pythagoras theorem in a new page. According to equation number 1, AO squared equals to R squared plus 33 squared according to equation number 2, BO squared equals to R squared plus 85 squared. According to equation number 3, OC squared equals to R squared plus X squared. Finally, according to equation number 4, OD squared equals to R squared plus 35 squared. Okay. next step, I will copy the rectangle ABCD with its circle inside, and we will do two constructions inside rectangle ABCD. So actually this is rectangle ABCD that I copied from the original drawing. We know that all the angles inside rectangle ABCD are right angles, so here those four angles, they are all right angles. In the next step, from the center of this circle, that is to say from this point, we'll go perpendicular on AD. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and AD as T, but because of the fact that the side AD is parallel to side BC, it means that if we draw perpendicular on AD, that perpendicular will be also parallel to BC because of the fact that AD is parallel to BC. So here, this angle will be also equal to 90 degrees, and this angle will be also equal to 90 degrees according to our construction. We define the touching point of the perpendicular from point BC. We define the touching point of the perpendicular from point O and BC as M. In the next step, we draw perpendicular from point O to AB. So this angle equals to 90 degrees, and this angle will be equal to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and AB as point S, but because of the fact that side AB in rectangle ABCD is parallel to DC, it means that the perpendicular on AB must be also perpendicular on DC, because AB is parallel to DC. So here, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and DC as H. So here in quadrilateral ASTO we have 1, 2, 3 right angles. The sum of right angles is 270 degrees. Therefore, the fourth angle must be also equal to 90 degrees, because 270 degrees plus 90 degrees it is 360 degrees. That is the sum of the angles in any quadrilateral. That is the sum of the angles in any quadrilateral. Likewise, in quadrilateral TODH, we have 1, 2, 3 right angles. Therefore, the fourth angle must be also equal to 90 degrees for the same reason. Likewise, in quadrilateral SBOM, we have 1, 2, 3 right angles. Therefore, the fourth angle must be also equal to 90 degrees. And finally, in quadrilateral OMHC, we have 1, 2, 3 right angles. Therefore, the fourth angle must be also equal to 90 degrees. Okay, so actually we created here 4 rectangles. Inside the big rectangle ABCD, we have 4 rectangles. Why? Because we have 4 quadrilaterals, that each quadrilateral has 4 right angles. Therefore, inside rectangle ABCD, we have 4 small rectangles. Okay. In the next step, we will define side AT as H1. We will define side TD as H2. We will define side AS as B1. And we will define side SB as B2. And we also note that the opposite sides of a rectangle are equal to each other. So if we focus on rectangle ASTO, its opposite sides are equal to each other. That is to say, AT equals to SO. AT equals to SO. But we know that AT equals to H1, therefore SO must be also equal to H1. Likewise, according to the sum of the opposite sides of rectangle are equal to each other, we get that AS equals to TO. AS equals to TO, but we know that AS equals to B1, therefore TO must be also equal to B1. In the next step, we will focus on rectangle TODH. In rectangle TODH, we know that TO equals to DH. TO equals to DH. But we found out that TO equals to B1, therefore DH must be also equal to B1. Likewise, in the same rectangle TODH, we know that TD equals to OH. But we know that TD equals to H2, therefore OH must be also equal to H2. And in rectangle ABOM, side SB must be equal to side OM. But we know that SB equals to B2, therefore OM must be also equal to B2. Likewise, according to the same rule, SO equals to SM. SO equals to SM. SO equals to BM. SO equals to BM. But we know that SO equals to H1, therefore BM must be also equal to H1. And finally, in rectangle OMHC, OH equals to MC. OH equals to MC, but we know that OH equals to H2, therefore MC must be also equal to H2. And we also know that M equals to HC, but OM equals to B2, therefore HC must be also equal to B2. Okay, so in the next step, we join points A and O together by a straight line. And we focus on the right triangle, ASO. In this right triangle, ASO, AO square equals to B1 square plus H1 square. I'll repeat again. In the right triangle ASO, AO square equals to B1 square plus H1 square. Okay, in the next step, we join points O and B together by a straight line. So in the right triangle SBO, BO square equals to B2 square plus H1 square. I repeat again, in the right triangle SBO, BO square equals to B2 square plus H1 square. We join points O and C together by a straight line. So in the right triangle OMC, OC square equals to B2 square plus H2 square. Repeat again, in the right triangle OMC, OC square equals to B2 square plus H2 square. And finally, we join points O and D together by a straight line. So, in the right triangle DOS, OD square equals to B1 square plus H2 square. Again, OD square equals to B1 square plus H2 square. Okay, so created another 4 equations for AO square, BO square, OC square, and OD square. In the next step, we'll create another 4 equations. From those 8 equations, we'll create another 4 equations. Equation number 1 states that AO square according to equation number 1 must be equal to AO square according to equation number 2. So AO square according to equation number 1 equals to R square plus 33 square. and it must be equal to AO square according to this equation number 2, that is equal to B1 square plus H1 square. In the next step, we'll create the second equation that states that BO square according to equation number 1 must be equal to BO square according to equation number 2. So BO square according to equation number 1 is R square plus 85 square. And it must be equal to BO square according to equation number 2, that is actually equal to B2 square plus H1 square. In the next step, we create the third equation that states that OC square according to equation number 1 must be equal to OC square according to equation number 2. OC square according to equation number 1 is R square plus X square. And it must be equal to OC square according to this equation number 2, that is equal to B square plus H2 square. B2 square plus H2 square. And finally, we get the equation number 4 that states that OD square according to this equation number 1 must be equal to OD square according to this equation number 2. So OD square according to equation number 1 equals to R square plus 35 square. And it must be equal to OD square according to this equation number 2, that is actually B1 square plus H2 square. Okay, so in this way we created another new 4 equations. In the next step, we subtract equation number 2 from equation number 1. So equation number 2 minus equation number 1 is here. Equation number 2 is R square plus 85 square. Minus equation number 1, that is R square plus 33 square, minus R square plus 33 square. So we finished this side. Now we go to the other side of equation number 2. So equation number 2 in the other side is B2 square plus H1 square. Minus equation number 1 is minus B1 square plus H1 square. Okay. In the next step, we'll open the brackets on this equation number 5, and we get that R square plus 85 square minus R square minus 33 square, that is equal to B2 square plus H1 square minus B1 square minus H1 square. Here R square minus R square is 0, so R square gets cancelled. And here we have H1 square minus H1 square is 0. So what is left from equation number 5 after we cancelled those two expressions? What is left is actually in this side of the equation number 5, we left only with 85 square minus 33 squared. On the other side of the equation, it is equal to b2 squared minus b1 squared. Okay. In the next step, we subtract equation number 3 from equation number 4. Here, equation number 4 minus equation number 3 is actually, in equation number 4 we have r squared plus 35 squared minus equation number 3, that is r squared plus x squared. We finish with this side. Now in the other side of equation number 4 we have b1 squared plus h2 squared minus equation number 3, that is minus b2 squared plus h2 squared. In the next step we will open the brackets of this equation, equation number 6, and you get that according to equation number 6, r squared plus 35 squared minus r squared minus x squared equals to b1 squared plus h2 squared minus b2 squared minus h2 squared. So here r squared minus r squared is 0, so r squared will get cancelled. And we have h2 squared minus h2 squared, that is also 0, so h2 will also get cancelled. So what is left from equation number 6 after we cancel those two expressions? In this side of the equation we have left only 35 squared minus x squared, that is equal to b1 squared minus b2 squared. In the next step, we will multiply equation number 6 by minus 1. And we get that according to this equation, equation number 6, x squared minus 35 squared equals to b2 squared minus b1 squared. In the next step, we will create equation number 7 that states that b2 squared minus b1 squared according to equation number 5 must be equal to b2 squared minus b1 squared according to equation number 6. I'll repeat again. Equation number 7 states that b2 squared minus b1 squared according to equation number 5 must be equal to b2 squared minus b1 squared according to equation number 6. So b2 squared minus b1 squared according to equation number 5 is 85 squared minus 33 squared. And it must be equal to b2 squared minus b1 squared according to equation number 6, that is actually equals to x squared minus 35 squared. Okay, so actually according to equation number 6, actually found out that according to equation number 7, found out that 85 squared minus 33 squared equals to x squared plus 35 squared. We add 35 squared to this equation, equation number 7, And we get that according to equation number 7, 85 squared plus 35 squared minus 33 squared equals to x squared. $85 squared is 7,225 plus 35 squared is 1,225 minus 33 squared, that is 1,089, and it is equal to x squared according to this equation number 7. Here 7,225 plus 1,225 is 8,450 minus 1,089 equals to x squared. And 8,450 minus 1,089 is equal to 7,631, that is equal to x squared. Therefore, we take a root out of this equation number 7, and you will get that according to equation number 7, x equals to plus minus the square root of 7,631. So here we have two possible solutions for x. One is a positive solution and the next one is a negative. But because of the fact that ax is a length, s as a length must be a positive number, so we take into account only the positive solution. That is to say, x equals to the positive square root of 7,631, that is actually equals to positive 85.796 units. Okay, the answer to the question is the length of line segment x equals to 85.796 units. The length of this line segment x equals to 85.796 units. We finished with the first question. In the next step, I will present to you the second question, and we will solve the second question in two different methods. In the drawing, we have a semicircle. We know that the diameter of this semicircle AB equals to 6 units. Angle BAC, this angle equals to 30 degrees. And our mission is to find out the value of the green area, the green shape. So we'll start with the first method. And here we define the center of the semicircle as O. We know that the diameter AB equals to 6 units, and the radius is half the diameter. Okay, so if the diameter is 6 units, it means that the radius must be equal to half of it, that is 6 over 2 is 3. So the radius AO equals to 3 units, the radius OB equals also to 3 units, and here point O is the center of the semicircle, point C is a point on the semicircle itself. Therefore, OC it is also the radius of the semicircle, that is equal to 3 units. Okay, so in triangle AOC, in this triangle AOC, side AO equals to side OC, both sides are equal to 3 units, therefore they are equal to each other. And we have the rule that in front of equal sides in the triangle there are equal angles. So those two angles that are located in front of equal sides must be equal to each other. But we know that this angle equals to 30 degrees, therefore this angle that is equal to it must be also equal to 30 degrees. So inside triangle AOC, we have this angle equals to 30 degrees, this angle also equals to 30 degrees. 30 degrees plus 30 degrees is 60 degrees, therefore the missing angle must be equal to 120 degrees. In order to complete the sum of the angles in triangle AOC to 180 degrees, this angle must be equal to 120 degrees. Okay, what is the area of a sector? What is the area of a sector? So if we have here this sector, it could be any sector, this is sector OAB, that could be any sector. OB is the radius of the circle, OA is also the radius of the circle, that is equal to R, and the angle between the legs of sector O and B is theta. Then the area of this sector will be equal to the area of the circle that consists this sector, that is pi r squared, times theta over 360 degrees. The ratio theta over 360 degrees gives us the relative percentage that this sector occupies out of the entire circle, and when we will multiply this relative percentage by the area of the entire circle, we will get exactly the area of this sector. So the area of this sector equals to pi r squared times theta over 360 degrees. We will implement the new formula in order to find out the area of sector AOC. What is the area of this sector? Sector AOC. Here I copy the sector here. We have the two legs are both equal to 3 units. So actually, this is sector AOC that I copied from the original drawing. And according to the new formula, the area of this sector will be equal to pi r squared. R is 3, so pi r squared is pi times 3 squared times the angle between the legs of the sector, that is 120 degrees over 360 degrees. So here 3 squared is 9, so this expression in total equals to 9 pi, and 120 degrees over 360 degrees is 1/3, so it is all divided by 3. 9 over 3 is 3, so in total this expression equals to 3 pi. So I found out that the area of sector AOC equals to 3 pi square units. This is the sign for the area of sector AOC. It is equal to 3 pi square units. In the next step, I will present to you a new formula for the area of any triangle. So if we have triangle ABC, here this is triangle ABC, that could be any triangle. And we know that the length of side AB is A units, side AC equals to B units in its length, and the angle between side AB and side AC is theta. Then according to the new formula, the area of this triangle, triangle ABC, is equal to A times B times sinus theta over 2. I'll repeat again. The area of this triangle, triangle ABC, that could be any triangle, equals to A times B times sinus theta over 2. We'll implement this new formula in order to find out the area of triangle AOC. So I copy triangle AOC here on the new page. The new page will implement the new formula in this triangle, triangle AOC. So this is actually triangle AOC that I copied from the original drawing. According to the new formula, we get that the area of this triangle, triangle AOC, will be equal to 3 times 3 times sinus 120 degrees over 2. That is to say, the area of triangle AOC equals to 3 times 3 is 9, sinus 120 degrees is square root of 3 over 2, all divided by 2. So in conclusion, we found out that the area of triangle AOC equals to 9 times square root of 3 over 2 times 2 is 4. So here we found out that the area of triangle AOC is equal to 9 times square root of 3 over 4 square units. And we have already found out that the area of sector AOC, is equal to 3 pi square units. Okay. But what is actually the area of the green shape? From the drawing, it is very easy to see that the area of this green shape equals to the area of sector AOC minus the area of triangle AOC. Again, the area of sector AOC minus the area of triangle AOC equals to the area of the green shape. So I write it down. The area of the green shape equals to the area of sector AOC minus the area of triangle AOC. I repeat again, the area of the green shape equals to the area of sector AOC minus the area of triangle AOC. We have already found out that the area of sector, this is sector AOC, the area of sector AOC equals to 3 pi square units minus the area of triangle AOC. We have already found out that the area of triangle AOC equals to 9 times square root of 3 over 4 square units. That is to say, the area of the green shape equals to either 3 pi minus 9 times square root of 3 over 4 square units, or in terms of numbers, it is equal to 5.53 square units. Okay, repeat again. The area of this green shape equals to either 3 pi minus 9 times square root of 3 over 4 square units, or in terms of numbers, it is equal to 5.53 square units. We finished with the first method. In the next step, I will present to you how to find out the area of this green shape according to the second method. We have another way to find out the area of the green shape. What is the area of the green shape according to the second method? The area of the green shape according to the second method will be equal to the area of the semicircle minus the area of triangle AOC minus the area of sector COB. Minus the area of sector COB. I repeat again the formula. The area according to the second method, the area of the green shape equals to the area of the semicircle minus the area of triangle AOC minus the area of sector COB. What is the area of the semicircle? The area of the semicircle equals to the area of the circle over 2. That is to say, it is equal to pi r square over 2. I'll repeat again, the area of the semicircle equals to pi r square over 2. We know that r equals to 3, so the area is pi times 3 square over 2. 3 square is 9, so this expression in total equals to 9 pi over 2. So we found out in conclusion that the area of the semicircle equals to 9 pi over 2 square units. We have already found out in the first method that the area of triangle AOC is equal to 9 times square root of 3 over 4 square units. And finally, we have to find out the area of sector COB. What is the area of this sector? Sector COB. We actually know that AB is the diameter of this semicircle. AB is the diameter, must be a straight line. It is absolutely a straight line. So if we focus on the upper side of the straight line AB at point O, here the sum of the angles must be equal to 180 degrees. So which angles we have at the upper side of AB at point O? We have this angle that is equal to 180 degrees plus the missing angle. In total, they must be equal to 180 degrees. Therefore, the missing angle must be equal to 60 degrees. In order to complete the sum of the angles on the upper side of AB at point O to 180 degrees, the missing angle must be equal to 60 degrees, because 60 degrees plus 120 degrees is 180 degrees. That is the sum of the angles on one side of a straight line. Okay, so we found out that angle COB equals to 60 degrees, and according to the formula of a sector, we know that the area of any sector is equal to pi r squared times theta over 360 degrees. Okay, the area of a sector, the area of any sector equals to pi r squared times theta over 360 degrees. Theta is the angle between the legs of the sector, and r is the radius of the circle that consists the sector. Therefore, according to this formula, the area of sector COB will be equal to pi r squared. R equals to 3, so it is pi times 3 squared times theta. The angle between the legs of sector COB is 60 degrees, so it is 60 degrees over 360 degrees. So in conclusion, we found out that the area of sector COB equals to pi times 3 squared times 60 degrees over 360 degrees. 3 squared is 9, so this expression in total equals to 9 pi, and 60 degrees over 360 degrees is 1 over 6. So here we divide both the numerator and the denominator of this expression by 3. 9 over 3 is 3, so in the numerator we have only 3 pi. In the denominator we have 6 over 3 is 2. So in conclusion, we found out that the area of sector COB equals to 3 pi over 2 square units. Okay, so I'll repeat again on the formula for the area of the green shape according to the second method. The area of the green shape according to the second method equals to the area of the semicircle minus the area of triangle AOC minus the area of sector COB. Okay. We have already found out that the area of the semicircle equals to 9 pi over 2 square units minus the area of triangle AOC. We have already found out that the area of triangle AOC equals to 9 times square root of 3 over 4 square units minus the area of sector COB. We just now found out that the area of sector COB equals to 3 pi over 2 square units. So here we have 9 pi over 2 minus 3 pi over 2 is 6 pi over 2 minus 9 times square root of 3 over 4. 6 over 2 is 3, so in total this expression equals to 3 pi minus 9 times square root of 3 over 4 square units. So we found out that the area of the green shape according to the second method equals to either 3 pi minus 9 times square root of 3 over 4 square units, or in terms of numbers it is equal to 5.53 square units. We finished with the second question. In the next step I'll summarize the lecture. We start with the first question, of course. In the drawing we have rectangle ABCD. Inside rectangle ABCD we have a circle. The tangent from point A to this circle is equal to 33 units in its length. The tangent from point B to this circle is equal to 85 units in its length. The tangent from point C to this circle is unknown. That is the tangent that we are looking for. So it is equal to x, and we have to find out the value of x. And finally, the tangent from point D to this circle is equal to 35 units in its length. And I repeat again that our mission is to find out the length of tangent x. Okay? So first of all, we defined the center of the circle as O. We joined points O and M together by a straight line. Point O is the center of the circle. Point M is the point of the circle itself. Therefore, OM is the radius of this circle that is equal to R according to our definition. We have the radius OM that is drawn to the point of tendency. Therefore, according to rule number 1, this angle equals to 90 degrees. Likewise, we repeated on the same process. Here also, we join points OE and O and E. OE is the radius that is drawn to the point of tendency. Therefore, according to rule number 1, this angle equals to 90 degrees. Likewise, OT is the radius that is drawn to the point of tendency. Therefore, according to rule number 1, this angle equals to 90 degrees. And finally, we have the radius OF that is drawn to the point of tendency. Therefore, according to rule number 1, this angle equals to 90 degrees. Then we joined points A and O together by a straight line. So, and we implemented the Pythagoras theorem on the green line triangle AOE. According to the Pythagoras theorem, AO square equals to OE square plus AE square. In the green triangle, AO square equals to OE square plus AE square. So AO square equals to OE. OE square, OE is R, therefore OE square is R square plus AE square. AE equals to 33, therefore AE square equals to 33 square. So in conclusion, we found out that according to equation number 1, AO square equals to R square plus 33 square. Then we joined points B and O together by a straight line. In this way, we created the yellow line triangle BOF. Then we implemented the Pythagoras theorem on the right yellow triangle BOF. According to the Pythagoras theorem, BO square equals to OF square plus BF square. I'll repeat again. In the yellow right triangle BOF, by PT is the relation from Pythagoras theorem, BO square equals to OF square plus BF square. So BO square equals to OF square. OF equals to R, therefore OF square is R square plus BF square. BF is 85, therefore BF square is 85 square. So in conclusion, we found out that according to equation number 2, BO square equals to R square plus 85 square. Then we joined points C and O together by a straight line. In this way, we created the right orange triangle OTC. In the right orange triangle OTC, according to the Pythagoras theorem, OC square equals to OT square plus TC square. Repeat again. In the orange triangle OCT by PT, OC square equals to OT square plus TC square. So OC square equals to OT square. OT is R, therefore OT square is R square plus TC square. TC is X, therefore TC square is X square. So in conclusion, we found out that according to question number 3, OC square equals to R square plus X square. And finally, we joined points O and D together by a straight line. In this way, we created the pink triangle, the right pink triangle MOD. In the right pink triangle MOD, according to the Pythagoras theorem, we get that OD square equals to OM square plus MD square. Here, OD square equals to MD square plus OM square. So OD square equals to OM square. OM is R, therefore OM square is R square. MD equals to 33 units, therefore MD square is 33 square. So in conclusion, we found out that according to equation number 4, OD square equals to R square plus 33 square. Then I copied the 4 equations in a new page, and those are the 4 equations that I copied to a new page, and then I copied rectangle ABCD in this new page, and we have the circle inside the rectangle, and we did 2 constructions from the center of the circle, that is to say, from point O we drew perpendicular on BC. So this angle equals 90 degrees and this angle equals 90 degrees according to our construction. But because of the fact that BC is parallel to AD, so if the straight line that we draw is perpendicular to BC, it must be also perpendicular to AD. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. Likewise, from point O, we go perpendicular on AB. So here, this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. But because of the fact that AB is parallel to DC, the perpendicular to AB must be also perpendicular to DC, because AB is parallel to DC. So this angle equals to 90 degrees and this angle also equals to 90 degrees according to our construction. We know that all the angles inside rectangle ABCD are right angles, so those four angles are all right angles. So here, inside quadrangle ASTO, we have 1, 2, 3 right angles. Therefore, the sum of 3 right angles is 270 degrees, plus the fourth angle. In total, they must be equal to 360 degrees. Therefore, the fourth angle must be also equal to 90 degrees, because 90 degrees plus 270 degrees is 360 degrees. The same thing is true in quadrangle TODH. We have 1, 2, 3 right angles. Therefore, the fourth angle must be also equal to 90 degrees. And the same thing is true in quadrangle SBMO. Here we have 1, 2, 3 right angles, therefore the fourth angle must be also equal to 90 degrees. And finally, in quadrangle OMCH, we have 1, 2, 3 right angles, therefore the fourth angle must be also equal to 90 degrees. So inside rectangle ABCD, we have 4 quadrangles, and each quadrangle has 4 right angles, therefore all the quadrangles in rectangle ABCD are rectangles, because any quadrangle that has 4 right angles, it is a rectangle. So inside rectangle ABCD, we have 4 small rectangles. Okay, and then we define side AT is edge 1, side TD is edge 2, side AES is B1, and side SB is B2. Then we focus on rectangle AESTO. We know that the opposite sides of rectangle AESTO are equal to each other. That is to say, AS equals to TO. But AS equals to B1, therefore TO must be also equal to B1. Likewise, AT equals to SO, but AT equals to H2, AT equals to H1, therefore SO must be also equal to H1. Likewise, in rectangle TOD edge, TO equals to D edge, but TO equals to B1, therefore T edge must be also equal to B1. Likewise, TD equals to OH, but TD equals to H2, therefore OH must be also equal to H2. The same thing we did in rectangle SBOM. SB equals to OM, but SB equals to B2, therefore OM must be also equal to B2. Likewise, in rectangle SBOM, SO equals to BM, but SO equals to H1, therefore BM must be also equal to H1. Likewise, in rectangle OMHC, OM equals to B2, therefore HC must be also equal to B2. Likewise, OH must be equal to MC, but we know that OH equals to H2, therefore MC must be also equal to H2. Okay, then we joined points A and O together by a straight line, and here in the triangle AOS, according to the Pythagoras theorem, B1 square plus H1 square equals to AO square. Okay, so here I repeat again, AO square equals to B1 square plus H1 square. Then we join points O and B together by a straight line. In rectangle, in triangle OB, the right triangle OBS, OB square equals to B2 square plus H1 square. Again, in triangle BOS, BO square equals to B2 square plus H1 square. Then we join points O and C together by a straight line, and here we have the right triangle OCH. In the right triangle OCH, OC square equals to B2 square plus H2 square. OC square equals to B2 square plus H2 square, and finally we join points O and D together by a straight line. In the right triangle ODH, OD square equals to B1 square plus H2 square. Okay, again, OD square equals to B1 square plus H2 square. Then we created another 4 equations. The first equation is AO square according to equation number 1 must be equal to AO square according to this equation number 2. Okay. Then the second equation states that BO square according to equation number 1 must be equal to BO square according to equation number 2. Then the third equation states that OC square according to equation number 1 must be equal to OC square according to equation number 2. And finally, OD square according to equation number 1 must be equal to OD square according to equation number 2. So those are the 4 equations that we created according to the 4 statements that I mentioned. Thus, right now, those are the 4 equations. Then we subtracted equation number 1 from equation number 2. Okay, so 2 minus 1. Equation number 2 states that r square plus 85 square, here minus equation number 1, that is r square plus 33 square. So we finish with this side, and then we subtracted the other side of equation number 1 from equation number 2. So equation number 2, in the other side we have B2 square plus H1 square minus equation number 1, that is B1 square plus H1 square. Then we open the brackets of equation number 5. So here we have r square plus 85 square. We have minus before the bracket, so it is minus r square minus 33 square. That is equal to B2 square plus H1 square. We open the brackets, we have minus before the bracket, so it is minus B1 square minus H1 square. R square minus R square is 0, so R square will get cancelled. H1 square minus H1 square is 0, so H1 square will also get cancelled, and we left only in equation number 5, 85 square minus 33 square equals to B2 square minus B1 square. Then we subtracted equation number 3 from equation number 4. So equation number 4 is r square plus 35 square minus equation number 3 minus r square plus x square. That is equal to equation number 4 is b1 square plus h2 square minus equation number 3, that is minus b2 square plus h2 square. Then we open the brackets of this equation number 6, and we found out that here r square plus 35 square minus, we have minus before the bracket, so it will become minus r square minus x square equals to, we open the brackets on this side of equation number 6, so it is b1 square plus h2 square. We open the brackets, we have minus before the bracket, so it will come to minus b2 square minus h2 square. Here we have r square minus r square is 0, so r square will get cancelled, and is equal to h2 square minus h2 square is 0, so h2 square will also get cancelled, and we left only the 35 square minus x square, that is equal to b1 square minus b2 square. Then we multiply this equation number 6, by minus 1. So here it will be b1 square will become to minus b1 square, and minus b2 square will become to plus b2 square. So here we have b2 square minus b1 square, that is equal to minus x square will become to plus x square, and plus 35 square will become to minus 35 square, because we multiply it by minus 1. So in conclusion, we found out that according to equation number 6, x square minus 35 square equals to b2 square minus b1 square. Then we created equation number 7 that states that b2 square minus b1 square according to equation number 5 must be equal to b2 square minus b1 square according to equation number 6. So here b2 square minus b1 square according to equation number 5 is 85 square minus 33 square, and it must be equal to b2 square minus b1 square according to equation number 6, that is equal to x square minus 35 square. So in conclusion, found out that according to equation number 7, 85 square minus 33 square equals to x square minus 35 square. Then we added 35 square to this equation number 7, we found out that 85 square plus 35 square minus 33 square equals to x square. 85 square is 7,225 plus 35 square. 35 square is 1225 minus 33 square is 1089, that is equal to x square. 7,225 plus 1225 is 8,450 minus 1089 equals to x square. 8,450 minus 1089 is 7,631, that is equal to x square. So in conclusion, we found out that according to equation number 7, x square equals to 7,631. We took out of this equation number 7, we found out that x equals to plus minus the square root of 7,631. So x will have here two solutions, the positive solution and the negative solution. But because of the fact that x is a length, it must be a positive number, so we take into account only the positive solution. That is to say, we found out that the value of x, it is equal to the positive square root of 7,631, that is actually equals to 85.796 units. So we found out that the length of this line segment x equals to 85.796 units. Okay, we finished with the first question. Then I presented to you the second question, and we solved the second question in two different methods. In the drawing, we have a semicircle. You know that the diameter of this semicircle is 6 units. We also know that this angle BAC equals to 30 degrees. And our mission is to find out the area of this green shape. Okay, so first of all, we define the center of this semicircle as O. We know that the diameter is 6 units, and the radius of any circle is half the diameter. So if the diameter is 6, it means that the diameter must be half of it, that is to say it must be equal to 6 over 2, that is 3. So the radius AO equals to 3 units, the radius OB equals to 3 units, and the point O is the center of the semicircle, point C is the point of the semicircle itself, therefore OC is also the radius of the semicircle, it is equal to 3 units. So in triangle AOC, OC equals to AO, they are both equal to 3 units, they are the radii of this semicircle, therefore they are equal to each other. And we have the rule that in front of equal angles in the triangle, there are equal, in front of equal sides in the triangle, there are equal angles. So those two angles that are located in front of equal sides must be equal to each other. But we know that this angle equals to 30 degrees, therefore this angle must be also equal to 30 degrees. So in triangle AOC, this angle equals to 30 degrees, this angle also equals to 30 degrees. 30 degrees plus 30 degrees is 60 degrees, therefore the missing angle must be equal to 180 degrees. In order to complete the sum of the angles in triangle AOC to 180 degrees, this angle must be equal to 120 degrees. Okay? What is the area of a sector? Here, if we have this sector A or B, that could be any sector, the legs of this sector are the radius of the circle that contains the sector, so it is equal to R, and the angle between the legs of the sector is theta. Then according to the formula, the area of this sector A or B, will be equal pi r square to pi r squared, that is the area of the entire circle, times theta over 360 degrees. The ratio theta over 360 degrees gives us the relative percentage that the sector occupies out of the entire circle. So if we multiply this percentage by the area of the entire circle, we get exactly the area of the sector. So the area of any sector is equal to pi r squared, that is the area of the circle, times theta over 360 degrees. We implemented the new formula in order to find out the area of this sector AOC. Okay, so I copy sector AOC here. So here AO equals to OC equals to 3 units. Those two sides are, those two legs are the radii of the semicircle, and the angle between the legs is 120 degrees. So according to the new formula, the area of this sector AOC will be equal to pi r square. R is 3, so pi r square is pi 3 square, times the angle between the legs of the sector, that is 120 degrees over 360 degrees. Pi 3 square is 9, so this expression in total equals to 9 pi. 120 degrees over 360 degrees is 1/3. So here we get that this expression in total equals to 9 pi over 3. 9 over 3 is 3, so this expression in total equals to 3 pi. So we actually found out that the area of this sector AOC equals to 3 pi square units. Okay? The area of sector AOC, here the area of this sector AOC, this is the sign for the area of a sector. The area of this sector AOC equals to 3 pi square units. What is the area of triangle AOC? Actually, I presented to you a new formula to find out the area of any triangle. The area of this triangle ABC, that could be any triangle. We know that the length of side AB is A units, the length of side AB is B units, and the angle between side AB and side AC is theta. Then the area of this triangle ABC, that could be any triangle, is A times B times sinus theta over 2. Again, the area of this triangle ABC is A times B times sinus theta over 2. We implemented the new formula in order to find out the area of triangle AOC. This is triangle AOC, and I copied from the original drawing. AO equals to OC equals to 3 units. Angle AOC equals to 120 degrees. So according to the new formula, the area of this triangle AOC will be equal to 3 times sinus 120 degrees over 2. 3 times 3 is 9. Sinus 120 degrees is square root of 3 over 2, all divided by 2. So in the numerator we have 9 times square root of 3. In the denominator we have 2 times 2, that is 4. So in conclusion, we found out that the area of triangle AOC equals to 9 times square root of 3 over 4 square units. And we have already found out that the area of sector AOC equals to 3 pi square units. But what is actually the area of the green shape? The area of the green shape equals to the area of sector AOC minus the area of triangle AOC. Very simple. Again, the area of this green shape equals to the area of sector AOC minus the area of triangle AOC. Repeat again, the area of the green shape according to the first method is equal to the area of sector AOC minus the area of triangle AOC. We have already found out that the area of sector AOC equals to 3 pi square units minus the area of triangle AOC. We have already found out that the area of triangle AOC equals to 9 times square root of 3 over 4 square units. In conclusion, we found out that the area of the green shape equals to 3 pi minus 9 times square root of 3 over 4 square units, or in terms of numbers, it is equal to 50.53 square units. Okay. Again, the area of this green shape equals to either 3 pi minus 9 times square root of 3 over 4 square units, or in terms of numbers, it is equal to 5.53 square units. Then I presented to you a second method to find out the area of this green shape. According to the second method, the area of this green shape will be equal to the area of the semicircle minus the area of triangle AOC minus the area of sector OBC. Okay, again, the area of this green shape equals to the area of the area of the semicircle. The area of the semicircle minus the area of triangle AOC minus the area of sector OBC. Repeat again. According to the second method, the area of the green shape equals to the area of the semicircle minus the area of triangle AOC minus the area of sector COB. What is the area of the semicircle? The area of the semicircle equals to pi r squared over 2. We know that r equals to 3, so pi r squared is pi 3 squared divided by 2. 3 squared is 9, so this expression in total equals to 9 pi over 2. So we found out that the area of the semicircle equals to 9 pi over 2 square units. We have already found out that the area of triangle AOC in the first method, it is equal to 9 times square root of 3 over 4 square units. The only thing that is left to do is to find out the area of sector COB. What is the area of sector COB? First of all, AB is the diameter of this semicircle, therefore it is absolutely a straight line. So if we focus on the upper side of the straight line AB at point O, here the sum of the angles must be equal to 180 degrees according to rule number 3. So which angles we have at the upper side of AB at point O? We have this angle that is equal to 120 degrees plus the missing angle. In total, they must be equal to 180 degrees according to rule number 3. Therefore, this missing angle must be equal to 60 degrees. In order to complete the sum of the angles on the upper side of AB at point O to 180 degrees, this angle must be equal to 60 degrees. Okay? So, we know that the area of any sector equals to pi r squared times theta over 360 degrees. R is the radius of the circle that contains the sector. Theta is the angle between the legs of the sector. We know that the radius of this circle, of this semicircle is 3, and the angle between the legs of sector COB is 60 degrees. So the area of sector COB is pi r squared. R is 3, so it is pi 3 squared times theta. The angle between the legs of sector COB is 60 degrees over 360 degrees. 3 squared is 9, so this expression equals in total to 9 pi, and 60 degrees over 360 degrees is 1 over 6, or 1/6. So this expression in total equals to 9 pi over 6. We divided both the numerator and the denominator by 3. 9 over 3 is 3, so in the numerator we have left with 3 pi. 6 over 3 is 2. So in conclusion, we found out that the area of sector COB equals to 3 pi over 2 square units. And then we know that the area of this green shape equals to the area of the semicircle minus the area of triangle AOC minus the area of sector COB. Repeat again, the area of the green shape according to the second method equals to the area of the semicircle minus the area of triangle AOC minus the area of sector COB. We have already found out that the area of the semicircle equals to 9 pi over 2 square units. We have already found out that the area of triangle AOC equals to 9 times square root of 3 over 4 square units. And finally, we have already found out that the area of sector COB equals to 3 pi over 2 square units. Here, 9 pi over 2 minus 3 pi over 2 is 6 pi over 2. So in total, this expression equals to 6 pi over 2 minus 9 times square root of 3 over 4. 6 over 2 is 3, so in total this expression equals to 3 pi minus 9 times square root of 3 over 4 square units. So in total, we found out in conclusion that the area of the green shape according to the second method equals to either 3 pi minus 9 times square root of 3 over 4 square units, or in terms of numbers, it is equal to 5.53 square units. I repeat again, the area of this green shape according to the second method equals to either 3 pi minus 9 times square root of 3 over 4 square units, or in terms of numbers, the area of this green shape equals to 5.53 square units. Okay, thank you very much.